Hi, I'm Michael Colton. This is a quick overview of the PSDR that I'm working on. First of all, the PSDR is my attempt at making a software-defined radio that will be well suited to backpacking use. So some of my design goals were to cover the bands I was interested, which is mostly HF, so that's like shortwave bands below 30 megahertz. It needed to be compact, light, good batteries, internal batteries. A lot of radios I see for portable operation. For example, the Yaesu A117 that I use a lot. It's great, but it works better with an external battery and an external antenna tuner and an external microphone, and it's not really that portable by the time you're ready to go. Anyway, so I want the PSDR to be nice and small and compact, but I also wanted to play with software-defined radio techniques. This is probably my second attempt at actually building a functional radio, so things are going pretty well. Anyway, so what we've got here is the radio's running. I'm kind of in the middle of some firmware changes, so not everything's working, but basically I've got it so that I can choose a center frequency, just turn the knob. You can click turn to move faster through frequencies. So what this is doing is this is setting the frequency synthesizer, or rather there's a pair of them that are right here. It goes through a bandpass filter, then through a line driver that takes the sine waves and turns them into square waves. That goes into the mixer, then to the amplifiers, and currently it's being piped into the computer. So it doesn't have any sort of real bandwidth limiting on it yet. So, and my computer happens to have a surprisingly good sound card, so I'm able to capture about 200 kilohertz at a time. Let me unmute it for you, see what these guys are talking about. Anyway, so you can see the RF section's working fairly well. I've got an antenna outside. It's a off-center fed dipole. Works okay, but I'm in like, I don't know, terrible interference in this neighborhood. So I don't know how much of how much of my performance is based on where I'm at and how much is the radio. I'm actually excited to get to the point where it will actually operate on its own. I can take it out backpacking and see how it really does. I'll probably do another video that's more in depth on how the circuitry works. I'm using Eclipse as a development environment. All the code's up on the GitHub repository. You can talk to the device, program it with these cheap little ST-Link debuggers, and you can single step through the code, things like that, change variables at runtime. It's pretty nice. It's using an STM-F4 processor, which is by far the beefiest microcontroller I've ever used. It's about 170 megahertz, has FPU and DSP capabilities like a mega flash, things like that. It's pretty sweet. I really like it. Anyway, so that's it in a nutshell, and I'll do more videos that go into a little bit more detail on the hardware design, how the software works. I have tons to do. At this point, I've got the waterfall display on the device works when the audio is not working. I can capture the audio, run it through the FFT algorithm, and then inverse FFT, and then feed it back out. I can do that right now. So this is the raw output from the RF section. It's being fed into the chip, which is processing it, but not doing anything really. And then this is the output. So what you can see here is that all of a sudden we get all these aliasing artifacts and stuff. That's because, again, there's no low-pass filtering. But we can still receive signals. We can still hear things. but they kind of all overlap each other. So probably sound kind of weird. Let's see what we get. Also, the bandwidth I'm trying to capture is a lot smaller than what the computer can get from the raw output. I realized pretty early on that trying to show like 200 kilohertz on the little tiny LCD is it's so cramped you can't tell what you're looking at, and probably unnecessary. I think I'll probably go for about 10 or 20 kilohertz on the waterfall. Anyway, that's about it. Power consumption's not terrible. It's coming along nicely. A few things I did with this board is, since there were a lot of things I'd never built before, I actually built it in sections. So I'll show you in a minute, but for example, rather than connecting the frequency synthesizers right to the filtering, right to the driver, I've just got some 0.1-inch headers breaking them up. So that way I can bypass things easily without having to cut traces. And then there's a bunch of things I left off, partially because I was in a hurry to get the PCB made, and I was just excited. So I left off things like a battery charge circuit and you know, like audio amplifier and stuff. Also left off some of the features that I want to implement later, like GPS. Anyway, so hopefully that's good for now. If you've got things that you want me to go into more detail about, let me know. That way I can prioritize what I do for these videos. But anyway, yeah, there it is. Thanks.